In the last video, we discussed the speed of sound in gases and air. In this one, we'll discuss the speed of sound in liquids and solids. Um, each of these equations for the speed of sound in these various medium looks largely the same. In liquids, the speed of sound is equal to the square root of the bulk modulus of the liquid divided by the density of the liquid. In solids, it's the square root of Young's modulus divided by the density of the solid. The bulk modulus and Young's modulus largely represent compressibility or stiffness of these materials. We can see the tables of values of density of bulk modulus and of Young's modulus. Let's do a little example problem with this. So we're interested in maybe the distance an object is away from a submarine. In order to measure that distance, the submarine will send out a ping. That ping will be reflected from the object, and then the submarine will detect that ping once it reaches the submarine again. So for this example, we're saying that the round trip time for this ping is 3 seconds. We're given the values of the bulk modulus and the density of seawater there at the last sentence on this slide. All right, so from this information, we'll try to figure out how far away this object is. Okay, as our first step, we'll pull out the equation for speed of sound in a liquid. And given the information that we had on the previous slide, if we plug those numbers into that equation, we should get out the result that the speed of sound in seawater, at least this seawater, is 1,507 meters per second. We're told that the round trip time for the sound is 3 seconds. Well, we really want just the half of that time, because that's going to be the time it takes the ping to travel from the submarine to the object. Half of that time would be 1.5 seconds. And now we can take advantage of the fact that speed is equal to distance over time. Rearrange that equation. Multiply our speed by the time it takes the ping to travel to the object. And when we do this, we get a distance of 2,260 meters from the submarine to that object. And of course, that could be useful information to keep the submarine from striking an object, or if there's some other reason why the submarine would want to know the distance. That does it for this one.